Everyone, welcome back to the channel. In this tutorial, we are going to learn Matplotlib, which is one of the most widely used Python libraries for data visualization. Okay, so far we have worked with Python, NumPy, and Pandas. We can store data, we can manipulate it and analyze it, but the important step here is to visualize the data. For example, instead of looking at the list of sales numbers, we may want to see whether sales are increasing or decreasing. We may want to compare different categories, understand the relationship between two variables, or see how our data is distributed. Okay, this is where Matplotlib becomes very useful. Okay, in this tutorial, we will learn Matplotlib in Google Colab practically. We will be creating line plots, bar plots, scatter plots, histograms, multiple plots, subplots, annotations, and we will also see how to save our visualization. So let's get started quickly. Okay. So first you have to import Matplotlib. For that you will write import matplotlib.pyplot. Okay, we'll be importing this pyplot library and let us use alias which will be as plt. It is a short name. Okay, so why do we use short names? So that we don't always have to keep writing the complete name. So we will simply import it. Okay, so before writing any code, let us see why visualization is actually important. Suppose I give you these numbers 42, 48, 45, 57, 63 and 72. You can read the numbers, right? But it takes some efforts to understand the overall pattern. These are very small set of numbers. There are large set of numbers. It is usually difficult to understand just by reading the numbers. Okay, now imagine the same numbers are represented as this graph. Okay, the pattern becomes immediately visible and visibly understandable. We can see that there is a small drop, okay, and then there is a steady increase. So visualization doesn't necessarily give us new information. Instead, it helps us understand and communicate information more quickly. That's why visualization is such an important part of our analysis. So what is Matplotlib? Matplotlib is basically a Python library which is used to create these visualization. The module we use it as pyplot and plt is its short name. Okay, this is simply a shorter name that makes our code easier to write. Okay, so once we have imported it, we can use commands such as plt.plot. This is for line charts, plt.bar for bar charts, plt.scatter for scatter plots, plt.hist for histograms. Okay, so let us try to run our first example. Okay, so first is line plot. A line plot is one of the simplest visualizations that we can create. Okay, let us create two lists. Here x and y are two lists that I have already created. Okay, x contains numbers from 1 to 5, y contains numbers 10, 15, 13, 20 and 25. Now to create our line plot, what I'll simply write is, I'll write plt.plot, plot is for line plot. I'll give x and y as input here. Okay, and I'll simply write plt.show. So it will show me the plot. Okay. Okay. So when I run this, we get our first Matplotlib graph. Okay. Here is the graph. Here the x values are represented on the horizontal axis and y values are on the vertical axis. Okay. Matplotlib takes the corresponding points and it is connecting them with a line. So with just a few lines of code, we have created a visualization. Before moving ahead, let us understand two terms that we will encounter later, but they are really very important. So this is the first plot that we have created. So these two terms are figure and axis. So think of a figure as the complete canvas or the page on which our visualization is created. Okay, and axes are the actual plotting area of that figure. Okay, so for a simple graph, we don't necessarily have to think about these concepts explicitly, but once we create multiple graphs, So in one figure, such as subplots, then these concepts become extremely useful. We'll see that in later part of this tutorial. Okay. So line plot, we have created our line plot. Let us do it with slightly realistic example. Suppose we have monthly sales data. Okay. So this is the monthly sales data from January to June. We will store the months in one list and the corresponding sales in another. Now let's try to plot them. Okay. So for plotting a simple line chart, I'll write plt.plot. Okay. And I'll give arguments months and sales. Okay. And I'll show the chart. But if I want to understand what my x-axis and y-axis are all about, I will write simply the x label and y label and title. Okay. So this makes the line plot clear. The visualization is slightly more readable. Okay. So in that case, I will get my title monthly sales. I will get on y-axis sales, on x-axis months. Okay. So with this, you can easily see that there is a small decrease from February to March, then sales increase steadily. So this is one of the main uses of line plots. So line plots are particularly useful for showing the trends or changes on an ordered sequence especially across a timeline. Okay. So if you want to further make this line plot clear, we will modify it. What we'll be doing is, we will be adding some grid lines here. Okay, before showing the plot, we will be adding the grid lines. So for that, I'll be writing plt.grid. Okay, so you can simply write grid is equal to true, or you can give the argument maybe 0.25. Okay, so that's how you do it. Another important thing, with adding the grid, you can also give the width of this line. Okay, here you have given the input in plot that months and sales. You can also give, okay, I want marker maybe is equal to, let's say, O. Okay, and maybe you can say line width is equal to let's say 2. Okay, so what it will give you, now it has given you the grid line. Okay, and it has given you O markers at the points where the values are there. Okay, and also the width of line is now, you can see the width of line. Okay, it is now 2. Perfect. Now let us try to understand where the line plot is used. So it is basically used for trends, the progress, and the time series. Okay. So message is clear. If you want to make your plot little more presentation ready, you simply add the x-axis, y-axis, monthly sales, these O markers. Okay, you can have other markers. Here we have written it 2. You can increase line width to 2. You can also add these grid lines. Okay. Next is the bar chart. So this is another common type of visualization. Suppose we want to compare average scores across 4 different subjects. Okay. Here we have separate categories. So bar chart is a natural choice. So let us first create our data. Maybe I have 2 subjects. Okay, I have subjects like Python, NumPy, Pandas, and AI, and scores of these different subjects. So if I want to create the bar chart, I'll simply write plt.bar. Okay, so let us try to see how it is created. So I have already created the list, which is my subjects and scores. Okay, now because I want to create the bar chart, what I'll be typing here is plt.bar, which will give me subjects, comma, scores. These two will be input. Okay, I am giving the title, X label, Y label, and finally showing it. Okay, so let us try to run it. So if you see it here, okay, this is the bar chart which is plotted. Now let us try to improve the bar chart slightly. Since our values of scores are out of 100 only, setting the y-axis from 0 to 100 makes sense. We can also add horizontal grid lines. So what we can do here is, we can add maybe a y limit. We can write plot dot y limit, say 0 to 100. Okay, we can also have grid lines like plot dot grid that we did earlier. You can where you want to have grid lines maybe on axis equal to y, and then maybe alpha equal to 0.2 here. So let us try to see how it looks. So we have now grid lines only on y-axis separated by 0.2, and then we have limit 100. So y-axis goes from 0 to 100. Okay. So again, this makes it easier to compare the height of the bars. Y-axis means that grid will be added only along the y direction. So our objective is the better readability. Now let's have a different question. Okay. Suppose we want to investigate whether students who spend more time in studying tend to get higher marks or not. Okay, so we are comparing two numerical values. We are comparing the relationship between two numerical values. We are trying to see whether one affects the other or not. Okay, so maybe we have two numerical values like study hours, this is the list, and the marks, and we will plot it using scatter, plt.scatter. Okay, so let's create a data. Let's try to do. So I have already created the data here, the study hours and marks. Okay, now a scatter plot is very useful for this type of data. For that, what I'll be writing is plot.scatter hours comma marks. Okay, x label, y label, title, maybe the grid line, and then I'll simply show my plot. Okay, so let us try to run it. Okay, you can now see it here. So every point here represents one observation. Okay, the x coordinate represents the study hours, y coordinate represents the exam score. Now if we look at the overall patterns, the points generally move upward. So in this example, we can see a positive relationship between study hours and marks. But remember, a relationship doesn't automatically means any causation. The graph helps us identify the patterns, but it doesn't prove that one variable causes the other. Okay. So in scatter plot, what should we basically look for? When we look at a scatter plot, there are several things we can investigate. First, we can look at the direction of the relationship. Does it generally move upward or downward? Second, we can look for the clusters. Are there any clusters being formed? Okay, then we can have, are there any groups of observation which are close enough, they are together enough? Then we can look for outliers as well. Okay, are there any points that are very different from the entire other rest of the points? So let us make our points slightly easier to see. For that, we can increase the size of these pointers. So for that, I'll simply write here f. So hours comma marks. Then the size, I will write size of the points, maybe let's say, okay, 55. Then you can see now the points are bigger in size. Okay, so it controls the size of the points. So it is especially useful when question about relationship between two numerical variables. Okay, so now let us look at the histogram. This is an important visualization, and I want you to remember the difference between histogram and a bar chart. So bar chart basically compares the categories, okay? But histogram, it takes, instead of looking at every individual scores, it takes, okay, in the particular range, how many individual scores, okay? So it basically plots the frequency of the scores. Maybe from, if we take the example of scores itself, so it gives me, okay, from range 40 to 50, how many students were there? From 50 to 60, how many students scored between 50 to 60? From 60 to 70, how many students scored between 60 to 70? So in that case, you will be writing, okay, I want to see these scores. I want to plot the histogram of the scores. But then I want the range from 40 to 50, 50 to 60, or how many bins I actually want. For that, you have to give the bin information, okay? Or you can either give the range or the number. So number of bins may be, say, 9. If you give the edge color, the edges will be black. These edges will be black, okay? Let us try to see this histogram. So basically it is giving us the distribution of data. So exam score, this is, I have already created this list exam score. So let's create a histogram. For that, I'll be writing plot.hist. Okay, hist is for histogram. I'll be giving exam scores here. Okay. The number of bins I have given 10. Edge color I have given black. So these are the labels, and I have also given the grid. So let us see what happens. So because there are 10 bins, each is having a grid line. It looks like this. If I simply remove this edge color, see what happens. Because I have given number of bins, it will give me equally separated bins. Now it is difficult to understand what it is looking like. Okay. Another thing is, if you basically trying to decrease the number of bins, it will give you more consolidated and more abstract information. Instead, if you write more number of bins, then it captures more fine details. Okay. So that is the whole point. Okay. So we are dividing the scores into intervals, maybe 40 to 50, 50 to 60. The height of each bar here represents the number of students whose score fall in that interval. So this chart helps us understand how values are distributed. Okay, the parameter I want you to remember here is bins. Bins basically determine how our numerical data is divided into intervals. Okay, so we first used only 5 bins, then 10 bins, then 15 bins. So you must have observed with fewer bins, the distribution is more summarized. As we increase the number of bins, we tend to see more details. So the choice of bin actually matters. Okay, too few bins, we may hide useful patterns. Too many bins, we make the visualization noisy. So the right choice depends upon the data and what we want the reader to understand. Now comes the multi-series. Okay. So multi-series, basically we are comparing two trends on the same graph. For example, we are comparing the number of students taking Python course and number of students taking maybe pandas. Okay. And over the months. Okay. So let us create the data first. So I have created the data here. Okay, so months are from January to June. Python students marks are here. Python students are here, the number of students. Now we are going to plot both these lines on a single graph. Okay, for that, because it is a line plot, we will be simply writing plt.plot. Okay, we'll be giving months, comma Python students, and then in the next plot, we will be giving months, comma Panda students. Okay, once we have given it, I will write X label, which is my months, Y label is number of students, then students are from two groups. So I will be giving one very important thing here, which is plt.legend. Okay, legend tells me which line refers to which group. Okay, so here the legend comes in blue and orange. If there was no legend, only the blue and orange line were there, then the reader would have kept guessing, okay, which what each line represents. Okay, so titles, labels and legends, these are the basic elements that make a visualization understandable. Okay. Okay. So if you talk about title, it tells us what the chart is all about. If you talk about the axis labels we are adding, so it tells us what is there in x-axis and y-axis. Legend tells us what is the meaning of each series. Okay. Grid basically is optional. It helps us estimating the values quite easily. Okay. Then is subplot. Okay. Now, sometimes we want to show several related visualization together. So, for example, we might want a line chart for a trend, a bar chart for a comparison, a scatter plot for a relationship, and histogram for distribution. So, we can pull out all four into one figure. So, for that, here we will be writing figure and x is equal to plot.subplots. How many plots I want to create? 4. So I will be taking 2 by 2. Okay. So I have created 2 by 2. Now this is 0, 0. This is 0, 1, 0, 0, 0, 1, 1, 0 and 1, 1. I'll now have to tell on 0, 0, axis 0, 0, I'll write my plot, which is my line plot. Axis 0, 1, I'll write bar plot. Axis 1, 0, I'll write scatter plot. Axis 1, 1, I write histogram. Okay. And figure dot tight layout. What does it mean? We don't want any charts or any lines to overlap with each other. So there it helps adjusting the spacing between the plots so that the labels and titles, they don't overlap. Okay. So this is where our earlier figure and axis concepts become useful. Sometimes this default size that is given of the canvas is not enough. Okay, for example, we are creating visualization for a presentation or for a report, and we may want a wider chart. Okay, we can in that case control the size using figure size. There is an important command called as figure size. Okay, we can maybe give figure size say 10 by 5, which is 10 units wide and 5 units high. Okay, this can be given. Sometimes there is one particular point we want to highlight. Okay, for that there is an important concept called as annotation. So it basically highlights the point which is very important that we want our readers to quickly capture. Okay, for example, highest sale value, so we use annotations for that. For that we will write plot dot annotate, but we want to annotate maybe peak. Okay, so for that we simply create a graph. Whatever graph we are doing, we simply write annotate plt dot annotate and write the values. Okay, and we also add labels. So here there are some arguments you might see. This is xy text, arrow props. Okay, so xy argument, it basically tells we want that where we want the text to appear. Okay, so xy argument tells Matplotlib which point we want to highlight. Okay, xy text basically tells where we want the text to appear, and arrow props basically controls the arrow. So it might be like, here is the arrow, this is the point, xy point we want to annotate, this is the arrow, and this is the area where the text will appear about this annotation. Okay, but use them very carefully. If everything is highlighted, then nothing looks important. Okay, now comes an important point, which is saving your chart. Okay, you have that visualization, but you want it to save it to your device so that you can use it in your reports, in your assignments, in your slides somewhere. For that, there is very important command called as save figure. Before plot.show, you will write this plot.save figure, and you will give the name of the file, okay, which is saletrend.png. That is the name and the extension of the file. You will give DPI information. Higher the DPI, sharper the image is exported. Okay. Then you can also give box inches is equal to tight, or like if you want, you can, this is entirely optional, you can even skip it. So it basically, the tight keyword here basically helps reduce unnecessary white spaces around the chart. Okay. So now we have our visualization saved as PNG file. Next comes Matplotlib plus pandas. Try to connect Matplotlib with something we have already learned, which is pandas. In real world data science projects, we generally don't create the lists manually. We are not creating the data manually. Instead, our data may be lying in CSV files, Excel files, or another databases. Pandas help to work with that data we know. Now we can use the panda to first read the data, clean it, filter it, group it, analyze it, whatever we have done. If you haven't watched that pandas video first, go watch it first, then come back and continue here. Once we have analyzed using Panda, we can finally visualize everything using Matplotlib. So very common data science workflow looks like we have data from Pandas, we perform the data analysis, then we have done visualization using Matplotlib, and we get some insights from the data. So we will explore this combination more when we work with the real data sets. Okay. Now comes choosing the right type of chart. Okay. How do we decide which chart to use? So instead of memorizing charts type randomly, start with a question you want to answer. Okay. If you want to answer how does something change over time, then use the line charts, line plot. Okay. If you want to compare like which category is larger, or you want to perform the comparison between variables, use the bar chart. If you want like to see how two numerical variables are related to each other, then use the scatter plot. Okay. And then if you want to see the numerical distribution of the numerical values, then use the histograms. So the best chart is the one that makes the intended comparison easiest. So some common visualization mistakes that you should understand. First, don't create a graph without its meaningful title. Okay, so that everybody can understand. Write the title, that is most important. Okay. Second, don't forget the axis labels, what x-axis and y-axis are telling. Okay. Third, avoid too many colors, because if everything is highlighted, nothing stands out. Okay. Fourth, don't choose a chart just because it looks attractive. The chart should match the question you are trying to answer. Okay. And finally, don't write the text so small so that the readers cannot understand. A technically correct visualization can still be a poor visualization if the audience or the readers cannot understand it or cannot read it. So ask yourself, can someone understand this chart quickly? Okay. So simple visualization workflow is what question I'm trying to answer, then what data do I need, what kind of visual chart fits my data and my question, and the context where I'll be clearly explaining it, clearly writing the title, legends, everything there. Okay. Then I'll finally check whether my visualization is proper, and if anybody who hasn't read the complete file can simply understand the context from my chart itself or not. Okay. Now there are some hands-on practice exercises that you must do before moving further. You should try to plot line plot, bar chart, scatter plot, and histograms using some lists. Okay. So the complete summary is, for line chart, you use dot plot, plt dot plot. For scatter plot, you will write dot scatter. For title, you write dot title. For legend, it is dot legend. For saving, it is dot save figure, the name and the extension of the file, and DPI information. Okay. For bar chart, it is simply dot bar. Histogram, simply dot hist, but here we provide bin information. How many bins do we want? Labels are X label and Y label. Grid is dot grid. You can also give maybe alpha value. Alpha is equal to 0.25 or something that we gave in our hands-on. Then for showing the plots, it is plt dot show. Okay. Now you can move the row numbers into clear visualization, but you remember to choose the chart for the question. Okay. Next, we will be basically combining pandas with Matplotlib on a real data set. Okay. We have learned all this. So in the next tutorial, we will take this further by combining pandas and Matplotlib with real data set. And now, if you find this tutorial useful and helpful, don't forget to like the video and subscribe to the channel. I'll see you in the next one. Thank you.